Hello and welcome to this Let's Talk Meshing video. Today we're going to go over an introduction to scripting in Pointwise using the Glyph scripting language. Now there are a number of benefits to scripting, but the primary benefit to me is that they allow you to customize Pointwise to your liking. That might mean changing the workflow or providing additional functionality. Now to this end, there's really two different types of scripts. The first would be a macro or utility script. This is a smaller script that will simply encapsulate a single task, and you might use several of these utility scripts for one gridding process. Now, these scripts might incorporate additional logic, might do something that you can't do through the GUI, and the whole point of them is to increase your productivity and provide you additional tools for generating your grids. The second type of script is a bit more involved to develop, but can be very, very useful, and those are templates or meshing scripts. These sorts of scripts will completely automate the meshing process from start to finish, and they're absolutely ideal for optimization routines or commonly gridded geometries because they can take your pre-processing and do everything for you automatically. However, they're not always practical because a lot of the times if you have a complex geometry or your grids change, a geometry changes significantly from one iteration to the next, creating a script each time is just not worth the time investment. Now, since this is a basic introduction, we're going to start at the beginning. Now, Glyph, as I mentioned before, is Pointwise's scripting language. However, Glyph is built on Tcl, or Tcl, the tool command language, which is a general purpose scripting language, and as such has its own syntax and everything else. So, some basic Tcl syntax for you. First of all, if you want to define a variable, you use set space x space 0. So this will take the value of 0 and assign it to this variable we've named x. If you then want to reference the variable x, you simply precede the variable name with the $sign. So for instance, if you wanted to print this to the screen, you'll use the puts statement, which is Tcl's print statement, or echo if you're familiar with shell. So by specifying puts $x, we're going to put to the screen the value of this variable x. If you want to perform an operation with this, you'll use the expression command, which is another Tcl construction. So here we're going to evaluate the expression. So the hard brackets mean evaluate and return the value. And then we're going to have an expression of x plus 2. So in this case, this is going, the $x is going to go reference this variable and return 0. So we're going to evaluate the expression 0 plus 2, which will give us a value of 2, and then we're going to set the variable y to that value. Tcl itself isn't necessarily an object-oriented language, but it does have some object-oriented like behavior and elements, such as lists. So here, we're going to set the variable myList to be a list consisting of 3 elements, 1, 2, and 3. If you then want to reference these elements, you can do so by using the lindex command. And so we're just going to say, all right, what is the 0th value in the variable myList? And since Tcl is uses zero-based indexing here, that's just going to go up here, return the 0th element in the list, which in this case is 1, and then print that to the screen. Now, scripting is not something that can be learned from watching a video or just reading a book. It really needs to be interactive. So here we're going to go through a couple of examples to give you a feel for how to develop these scripts. So first of all, let's use your favorite text editor to create a file named basics.glf. So your text editor can be Notepad, it can be WordPad, Vim, Emacs, VI, Notepad++. It's really up to you, but the idea here is you just want to generate a text file that you're going to change the extension of to .glf. Then at the top of this file, we're going to include the line package require pwi glyph2. So this is going to simply tell Tcl to load the Pointwise command so that we can access Pointwise entities here. The snippet that we're going to use in this basic script doesn't require this line, but it's good practice to include in all of your glyph scripts, because otherwise you can't access any of the Pointwise entities. Then we're just going to define a variable and do something with it. So with that, let me go ahead and pull up my text editor. So I have just a blank page, so we're going to just add this package require pwi glyph2, And then we're just going to define a variable and print it out. So let's just say set a equal to 3.14159. And so we're just defining the variable a to hold the value of pi out to 5 digits. Then we're going to go ahead and print this statement. And so we're going to say print a equals $a. So what this will do is it will actually go through, it will print this string, so a equals, and then the $sign is then going to call this variable and substitute its value. So that should print out the string a equals 3.14159. Then let's also go ahead and print out an expression of sine a divided by 2. So this again will take the variable a, substitute its value, divide it by 2, compute the sign of that quantity, and then print that out to the screen. So we can then save this script. We'll load up Pointwise, and then if we go up here to script and execute, we'll navigate to basics.glyph and then click on OK. And you can see down here in the message window, it did exactly what we wanted it to. It printed out the string a equals 3.14159, computed the sign of pi over 2, which should be 1, and here we have some numerical errors or round off errors that have entered the solution because we didn't specify pi out to 100 digits, and there's always going to be some numerical errors whenever you're doing floating point operations like this. So that's a basic script. I mean, scripting in general is that simple. It's just a matter of getting the commands you want and putting them on paper. Now, one of the challenging things about writing a script is knowing where to go to find out those commands to write. So because of that, I'm going to go a little out of order here and introduce the references before we go in and do a glyph scripting example. So for Tcl, both tcl.tk and wiki.tcl.tk have a lot of very good descriptions, examples, etc. of the commands built into Tcl. In order to reference them, I typically use my favorite search engine and search for the desired outcome. So if I wanted to sort a list in Tcl, I would search just that and then look for the results on tcl.tk, or maybe Stack Overflow or something like that. And then you can find suggestions, and you can pretty quickly find, using this search criteria, the lsort command, and you can get the options and flags that you can use with that. Now for pointwise commands, there's a couple of tricks in the GUI that we can use to find them, but there's also an online source that has all of the glyph commands listed with all of the options, etc., etc. So that's located at pointwise.com/glyph2. I'm going to go ahead and pull that up here. And so whenever you load pointwise.com/glyph, you can actually see it's going to look exactly like this. If you go down here to functions, which is what I had up just a moment ago, this is an A to Z listing. So you can reference any of the glyph functions here by the first name of the call. So here, if you want to add an edge, you can click on this and it'll give you information about how to go about adding an edge to a domain. But this is very overwhelming whenever you don't know what you're looking for and that sort of thing. So this is just a tool to give you more information. But what we really want to do is we want to look at scripts. So that's the best way to really immerse yourself in scripting, is to look at scripts. And so another reference you can look at is our GitHub repository. So there's a number of scripts that you can go and download. You can look and see how we approached certain scripting challenges and that sort of thing. You can get a lot of useful tricks out of those scripts as well. You can even cut and paste in a lot of cases. And so that's a very useful exercise as well. In terms of more training, there's a tutorial workbook there under the help menu in Pointwise, and the chapter 13, or the reentry vehicle tutorial, is a glyph scripting tutorial. So you can go through that. It will step you through step by step how to generate a script to create a grid, and that's actually a meshing script, a template script that will generate the entire grid for you. And then if you're really serious about scripting, you can actually come to a scripting course here in Fort Worth that we offer from time to time. And it's 3 days of hands-on training. It's a very great way to really come up to speed with scripting in Pointwise. If you're interested in that, just contact us. Now, when you're generating your own scripts, the first thing I like to do is I like to think about my workflow in Pointwise and evaluate whether or not what I'm doing would even be a good candidate for scripting, rather than just jumping in and starting to write a script. So the key rule is that anything that you can do in the GUI can be scripted. However, by its nature, the GUI allows a lot of user interaction. And anything that's going to require a lot of clicking or a lot of user interaction or user feedback is not a good candidate for scripting, because it's just, at that point, you're just going to be replicating the GUI, and there's no sense in doing that. In addition, a good script will meet at least a couple of these criteria. Should be like a frequently performed action. You don't want to spend a lot of time writing a script that you're only going to use twice. It should be maybe something that's tedious to do manually, or maybe it requires information that you can't get through the GUI easily. And then another important point that maybe should even be mandatory is that the script should have a reasonable scope. You shouldn't go out expecting to create a script in 10 minutes that's going to do all of your gridding problems start to finish. So some examples of good candidates for scripting would be creating an OH topology for a circular group of connectors, or applying a boundary condition to an existing group of domains, or maybe offsetting a point normal to a surface. These are all things that you can do through the GUI, but they're tedious. They might require some additional information, like the local normal, if you're looking to offset a point from the center of a database surface or something. But they're also very tractable and very reasonable scope. So it definitely hits on that last point. Some examples that aren't necessarily good scripting candidates would be creating a topology for a very specific geometry, or changing the display attributes of a domain, something that can be done in a click or two in the GUI, or dimensioning a connector, same sort of thing. However, all of these have asterisks because there might be situations where you do want to script them. For instance, changing the display attributes of a domain. Maybe you want to color the domain based on the minimum included angle of the cells in that domain. So you could easily write a script to loop through all of the domains in your grid, find the ones with a minimum angle less than 20 degrees, and shade them red. And that's something that would be very, very tedious to do by hand. Now, something before we get into the example is the way that I tend to go about finding glyph commands or discovering them, because the man pages are a great reference, but they're very daunting to go through and try to find something if you don't know what it's called. Everything that's done through the Pointwise GUI has a corresponding glyph command. That means anytime you click a button or draw a point, something is being sent to the code core through glyph. What that means is that in most cases, these commands can be echoed out to the message window or to a text file. So in both cases, we're going to actually be generating valid glyph script commands, and we can bookkeep those and look at those, inspect them, and find out the names of the commands that we need to use. However, a key point is that journaling syntax is algorithmically created. There's a lot of variable names that are temporarily generated and then promptly deleted. It's a very cluttered product, basically. So whatever's coming out of there will contain the relevant information you're after, but it really needs to be cleaned up. Journals are not meant to be standalone scripts. Now, to really drive this home, we're going to go ahead and hop back over into Pointwise and do an example. This example's basically a stripped down version of the squeeze_con script that's on our GitHub repository. The idea of this is a relatively straightforward and simple operation, but it copies a selected connector and places it between two specified points. And it's really just a combination of two transformations, but it has a lot of interesting features that really highlight how to go about developing these scripts. So with that, let me go ahead and pull Pointwise back up. Now, the first thing I want to talk about is journaling. And so as I mentioned a few minutes ago, journaling is a fantastic way of discovering glyph commands from the GUI that prevents you from having to search through the online man pages and really look for a command that you might not know the syntax to, or know even what the command might be called. So in order to enable journaling, the way I typically use it is I go down here to the message window, I right click, I go to preferences, and then I click on journal. Now, as long as there's a check mark by journal, any glyph command that the GUI creates is going to be echoed out to this message window. So if I go up here and create a 2-point connector and click OK, you're going to see a lot of information created and spat out underneath the heading of journal. So while, as I said earlier, journaling is very verbose and it's not at all clean and it's very cluttered, but That being said, it does still tell you the relevant commands that you need to know in order to develop your own script. So if we just step through this really quickly, you can see that the first thing that we do is we create this mode. We're not going to talk too much about modes, but you can think of them as kind of a container where you can create or change things, and then you can cancel out of it, or you can abort out of the mode, and no changes will be saved. But then we're going to go ahead and create this segment spline. Then we're going to add 2 points to that segment that we created. Then we'll create a connector, add the segment that we created above to that connector, calculate its dimension, and then end the mode. And that's really the basics of it. I mean, even though this looks very daunting, there's a lot of variable names, a lot of strange wording, etc., it's really straightforward in terms of what's going on. And so journaling is a fantastic way of getting these commands to do a specific operation in Pointwise that you can then go look it up on the Glyph website and find out the exact syntax, the options, what it's going to be returning to you, etc. So with that, I'm going to go ahead and pull open that example file that we talked about earlier. And so the other thing that I like to do whenever I'm journaling and working on creating this script, I like to go ahead and run through the entire process, start to finish, manually with journaling enabled so that I can get a feel for the commands that are going to be involved. So the first thing I'm going to do here is I'm actually just going to clear out the message window so it's a little cleaner. Then what I'm going to do is I'm going to, as I mentioned before, we want this operation, the script, to copy this connector, and we're going to translate it over here to lie on one of these other nodes, and then we're going to scale it to fit in between two selected nodes. So to do that by hand, what I'd probably do is I'd start by highlighting the connector, I'd copy it with Control-C, then I'd paste the connector with Control-V, then I'm going to apply a translation to it, and in order to specify the translation vector, I'm going to click that endpoint and click this endpoint, and then you can see that's moved that connector over to the center of this lower triangular domain. Unfortunately, we can't scale it right now because that point up there is not pickable, but we'll go ahead and accept that paste. Then we'll highlight the connector, we'll go up to Edit, Transform, Scale. Then we'll pick the point down below as the anchor. Then we'll pick the point up top as the beginning point of the scaling vector. And then we'll pick the node where we want that endpoint to lie as the second point. Then we'll click OK. And now you can see we have exactly the behavior that we were after. We've taken this connector, we've copied and scaled it so that it now fits perfectly between these two nodes. Now, if we go and look at the journaling output, you can see there's a lot of information here. But again, we can read through it if we kind of are selective in what we see. So the first thing we see is we cleared out the clipboard. So we erased everything else that might have been on the clipboard. Then we got that connector specifically by name, and that's something that we're going to need to do differently in the script because we want to be able to select any connector. We don't want to hard code the script so that it's always referencing this one connector. Then we set the clipboard to contain only that connector. Then we pasted it. We then started modifying it, and then we applied this transformation. So we had this PW entity transform, and we applied this transform translation to that entity. And then you can see we did some vector math here. We subtracted these 2 points, and those 2 points were those points that I selected here, the end point of this connector, and then this node where we wanted that endpoint, the connector, to lie. And then we applied it to the entity, so that pasted connector that we created. Then there's some more superfluous code that we can strip out. Then we got the new connector. Now we're going to start modifying it, and then we applied this scaling transformation. So again, it's a very similar operation to what we did before, and we provided some points to it, and what we can do is we can go to the man pages and figure out what points we need to provide to this operation. And then we ended it, and that's the end. At that point, we've completed the operation. So rather than go through and write this script in this video, that's going to take a little bit of time to describe every single step. Instead, I'm going to go ahead and pull up a completed script, and we're just going to step through it line by line. That way I don't have to worry about making typos. So the first thing that we want to do is we need to remember that the script needs to be somewhat versatile. And as I said, user interaction really needs to be kept to a minimum in these scripts, and it's for this reason. The script doesn't necessarily know where your mouse is or that sort of thing like the GUI does. So whenever you're talking about selecting points and providing information to it, that's something that you're going to have to code into your script. And so that's the primary difference between the script that we want to create and what was created by this journal. Because remember, if we scroll up here, the second line here in this journal was it got the connector by its name. And that's going to be something we called hard-coded, meaning it's not changeable. If we were to put that line in the script, then anytime we executed the script, it would always grab this connector, even if we wanted to copy and scale and translate a different connector. So what we want to do instead is we actually want to get a selected entity from the GUI. So here we're going to have to use some other commands that unfortunately aren't going to be printed out in any sort of journal, because the journal has the GUI to get these selections. It doesn't have to ask the user for anything, because we basically, in this script here, we need to replicate this functionality of the GUI. But there are a couple of commands, and there's a few ways of finding it. The way I would suggest is actually looking at our GitHub repository and looking at similar scripts that do things that you're trying to emulate. Or maybe it's not the exact same functionality, but maybe you say, oh, well, I need to get a loop of connectors, so maybe I should go look at the create OH script, because that requires a loop of connectors that I select after the script is being executed. And then you can go and look within that script and tear it apart and find relevant code snippets, and then you can copy and paste them. So in this case, you could go and look at the actual squeeze connector script on GitHub, and you could say, okay, well, at the very beginning, there's something that creates this mask, and the comments will kind of guide you a little bit. So this is just creating the selection mask, which is, in some sense, replicating what the selection masks do in the GUI. And we're going to require a connector. Meaning basically we're going to enable the selection mask to only pass selected connectors. Then we're going to call this command called get selected entities, and if we were curious about how that worked, we could go to the man pages, we could pull it up, we could go over here under the alphabetical listing to G, and then we could search for get selected entities, and you can see that it's right down here. We'll click on that function, and that'll bring up the definition and tell us about the options. And so you can see that the parameters here, it requires this result var, and this option specifies the name of the array variable to receive the results. So what this is going to do is it's going to go out, figure out what entities are currently selected in the GUI, and then it's going to return those results to this variable. This variable is an array, which we haven't talked about yet, but arrays are indexed with keys, basically. You can think of them as being kind of a named entity within this variable. And so in order to reference the connectors inside this result var array, we simply have to pass it the key of connectors. So that makes a bit more sense here in the script. So if we look over here, we're going to pass what the current selection to this variable called cur_selection. And then we're going to set the connector to whatever is in this array with the connector's key. And so this is now going to take everything that was currently selected in the GUI that is also a connector, because we passed it this selection mask, and set it to this variable con. Now the other thing that we need to make this script work is we need 2 points. So remember, whenever we did this transformation, we selected this connector. Now we selected one endpoint of that connector, but since we already have the connector, we could get that endpoint very easily just by looking at it as a function of arc length, for instance. But we did need this node over here and the corresponding node at the top. And so that's 2 more bits of input that we're going to have to code into the script. So in order to do that, there's another command that we can find either in another script or maybe on the online resources called select point. And so within pwdisplay select point, we're going to call that, we're going to require those points to be a node on an existing connector. And that's what this optional flag right here does. And we're going to get 2 of those, and those will be the beginning and the end point of the final connector. Now, as I mentioned before, one of the other points that we needed whenever we did that transformation is we needed the beginning point of the connector that we were copying. So here we're getting the beginning and end point of that original connector, And then we can actually print that out. So if we were to go ahead and run this script right now, we can go over here, we can go up to script, we can do execute, and we'll go up and grab this squeeze-con simple. Then we're just going to select 2 points because we were asked to select 2 points. And then you can see it'll spit out right down here the 2 points corresponding to the beginning and end point of that selected connector. So this get XYZ is just going to return the X, Y, and Z location of the point on this connector at the arc length of 0.0 or 1.0. So this is just the normalized arc length. So 0 would be the very beginning of the connector, 1 is the very end of the connector. So since we don't really need to print those points out, we can go ahead and delete those print statements. But then what we might want to do is we might want to say, okay, well, I want to find which of those points is closest to point 2. So I want to say, we're going to translate first from one of those endpoints of the connector to point 2. And how we're going to do that is we're simply going to do some vector math. And if we go back to the journal over here and scroll up, you can see that there was this PWU vector3 subtract. That suggested to us that there was some commands available here under vector3 that allows us to do vector math and add or subtract vectors and that sort of thing. And so what we can do is we can manually compute the vector between the end point of that connector that we've selected and the beginning point of that connector, and we can find which end point is closer to this point 2. And so that's what we've done here. We've got a difference A and a difference B, and then we're going to find whichever one is closest. So if diff A is less than diff B, then we're going to set point 1 to point 1A. And so that's just basically finding whichever point is closest to our point 2 that we've selected. Then our translation vector that we're going to pass to that transformation command that we have right down here, see, like basically this vector right here is what we're computing by taking the difference between point 2 and point 1. So that tells us the vector that we're going to apply. Here we're doing the exact same thing we did in the journal. We're going to clear the clipboard, then we're going to set the clipboard. We'll begin the paste. We're going to apply this translation vector and then apply that to the pasted entities, which in this case is this central connector. The other thing that we can do is we can then grab the endpoint of this connector. We can make sure that that endpoint is unique, and then we can go ahead and simultaneously do this scaling operation that we did here. So before we had to exit out of the paste mode, we then had to pick more points, we had to set the end point, but see here we've already know that we've translated that connector such that the endpoint lies exactly at point 2. And then we can simply specify these 2 additional points. We can then apply that scaling, clear the clipboard, and the operation's done. Now, one of the tricky parts about a good script is error handling and that sort of thing. So that's a little bit of what you see in here. There's some additional steps, but the idea behind scripting is that you can use journaling to very quickly come up with a framework that might do 99% of what you need it to in the script, but it might not handle certain cases very well. But the idea is you can always go back and add additional error handling or additional logic to your script to make sure that it behaves exactly like you want it. In fact, if you were to go to our GitHub repository and look at the script, the squeeze connector script, on the repository, there's a bit more complication in that script just because we wanted to make it a bit more robust. But you can see in a matter of minutes we can go from a journaled output from an interaction in the GUI to an operating script. And so my hope is that you can embrace this and try to start using scripting to kind of enhance your workflow a little bit in Pointwise. So with that, I'll go ahead and pull up the references and kind of wrap up here. I know that some of the finer points here in this video I went through a little quickly, and that's just because a lot of the intricacies of scripting would take a very long time to explain fully. But my hope is that with the help of these references in this video and some of the other example scripts we have on our script exchange, you'll have a bit more confidence in going and tackling your own scripting problems. So as always, feel free to post any questions you might have in the comments below or contact us directly. We're always happy to help answer your questions, and I really appreciate your time. Thank you very much.